All right, let's jump right into this explainer. Today we are unpacking OpenSquilla. It's an open source microkernel AI agent that's honestly making some really serious waves right now. It claims to drastically reduce your token costs while prioritizing Model Context Protocol, or MCP integration, right out of the box. So if you're building multi-step agents and you're just feeling the absolute sting of API costs, or if you're looking for a much more modular way to integrate tools, you're going to want to pay close attention to this one. Here's the roadmap for our deep dive today. 1. The token routing solution. 2. MCP as a first-class protocol. 3. Microkernel agent architecture. 4. Comparing agent frameworks. 5. Installing OpenSquilla. And finally, 6. The reality check. Okay, let's kick things off with Section 1, the token routing solution. Let's tackle the most immediate, glaring pain point developers face, right? Structural cost inefficiency. I mean, why pay frontier model prices for basic agent tasks? In a typical workflow, you're paying premium, top-tier rates for literally every single turn of the conversation. But a simple memory lookup or a basic tool dispatch, that doesn't require the massive reasoning power of a premium frontier model. Most frameworks completely ignore this because they're built around a single model per session. So yeah, you end up massively overpaying for basic chores. So by attacking this structural flaw head-on, OpenSquilla reports a massive 60 to 80% token cost savings. Let that sink in for a second. 60 to 80%. Now, quick caveat. We have to note this is a self-reported design goal, and your actual mileage is absolutely going to depend on your specific workload mix. But the strategy they're using to pull this off, that's what's genuinely fascinating. The secret sauce here is Squilla Router. Think of it exactly like ride-sharing. It evaluates the complexity of a prompt by looking at length, language, code presence, and semantic embeddings. So simple questions, they basically take the bus with a super cheap model. But complex reasoning, that gets the premium frontier ride. And here's the kicker. Because it runs locally right on your device using Onyx, it doesn't add any external API latency or extra token costs just to make that routing decision. It's incredibly smart. All right, moving on to Section 2, MCP as a first-class protocol. So looking at the framework's other major differentiator, OpenSquilla's design philosophy is crystal clear. They treat MCP as a first-class protocol rather than some afterthought. Instead of bolting MCP on later as a clunky, fragile plugin, this project builds it natively into its very core. And if you're a developer already using Claude Code and MCP servers, this is fantastic news, because it means the integration is seamless right from day one. The really crucial point here is that this direct integration lets you expose OpenSquilla's own built-in capabilities. Things like its internal web search, its multi-tier memory, or the task scheduler as MCP tools directly to a Claude Code session. You don't need some messy translation layer, it just connects. Plus, skill metadata and tool results are XML escaped at the data layer. That cleverly closes off common prompt injection vectors, which, let's be honest, is a huge relief. Which brings us to Section 3, microkernel agent architecture. So this native MCP integration and that local routing efficiency we just talked about, they're only possible because of how the underlying software is fundamentally structured. Inspired by actual operating systems, OpenSquilla's core engine is tiny. We're talking around 100 lines of code. It only handles state management and basic orchestration. Everything else lives in user space as an isolated plugin. So if an individual plugin crashes, it doesn't take down your whole agent workflow. It simply rolls back the error. It's incredibly resilient. The beauty of this 5-layer separation is the pure flexibility it gives you. You want to swap LLM providers? Go for it. It supports over 20, including OpenRouter, OpenAI, and Anthropic. Want to add a chat channel like Telegram or Slack? Easy. You don't have to rewrite your entire configuration schema. The tiny engine stays completely untouched while these plugins do all the heavy lifting. I mean, just look at the memory module alone. It is a massive achievement that plugs right into this architecture. It actually mimics human cognition across 4 distinct tiers, moving from immediate working memory all the way down to a raw audit base. It even has this wild memory dream consolidation process that runs every 24 hours. It literally takes scattered memories and structures them into long-term knowledge, using both vector semantic and full-text keyword searches. Okay, let's jump into Section 4, comparing agent frameworks. When you actually stack these frameworks side by side, the contrasts are pretty stark. OpenSquilla relies on that super compact microkernel we discussed, whereas something like Hermes Agent, it uses a heavily coupled monolithic main loop that is thousands of lines long. And for cost strategy, OpenSquilla's ActiveML routing is just vastly more sophisticated than, say, OpenClaw's static configuration fallbacks.
And we can't ignore security. OpenSquilla operates without needing Docker at all. No way, right? Instead, it uses OS-level sandbox tools for syscall-level isolation, specifically bubble wrap on Linux and seatbelt on macOS, alongside 3 risk-based policy tiers. It even has this cool denial ledger that will automatically pause the agent if it tries to bypass security policies too many times in a row. It's properly locked down.
Let's get practical with Section 5, installing OpenSquilla. So how do we actually get this running on your machine? The official docs give you 4 paths. If you're on Windows and you just don't want to mess with Python environments, there's a handy portable zip. Honestly though, the quick terminal install that uses the incredibly fast UV package manager, that is highly recommended for most users across all OS types. It just keeps the environment perfectly isolated and clean. Now, if you are installing from source, the process is pretty straightforward, but you gotta pay attention to step 1. It strictly requires Git LFS to pull down those local Onyx routing models. You cannot skip that. Once it's installed, there's a nice interactive wizard that easily configures your API keys and security policies before you spin up the gateway. Finally, Section 6, the reality check. Okay, before you rush off to deploy this everywhere, let's balance the marketing hype with the actual operational realities of running version 0.2.1. The architectural design is brilliant, absolutely, but there are caveats. Those 60 to 80% token savings? Remember, they're self-reported benchmarks. If you're in an enterprise environment, Windows Smart Screen is probably going to flag that unsigned portable build, and corporate firewalls might block the required Git LFS downloads. Also, managing configurations for 11 different chat channels at once, that can become an operational headache real fast. The advice here? Start small, verify your loop, and then expand. So, I want to leave you with this provocative thought to ponder. Does the undeniable token efficiency and that beautiful, clean MCP integration of a microkernel agent outweigh the complexities of running local routing models and managing early version software on your own hardware? It is a calculation every team is going to have to make for themselves. Thanks for joining me for this explainer, and keep exploring.